scale in that message. Once message will be taken, then we can't retrieve that message. Only once delivery, and this is first in, first out. Right.
Okay.
Okay. So delivery will be first in, first out.
Okay.
So I'll go through the PPT.
Yeah. So actually, why we need MQ actually?
So why we need is MQ is we provide assurance like the message will be last. So for example, if application Java application is writing some code, and that should be saved into the database.
Okay.
So that is what there is concern. So in the middle of MQ, what MQ will do in the middle? It's the middleware platform, right? MQ.
Yeah.
So MQ is placed into the middle of the Java and R. So once the application is put the message to the MQ, then that is will be picked up by the R and its database. So this database or something like when beginning of database to be restarted or something disconnected. So message will be existing to the MQ. So there won't be last of the message. Right. If Java directly tries to put the message into the database, if database if something else happened to the database, then message will be lost. But this time, if Java will putting that message into the MQ, and from there database is picking up, then if database will see some problem, the message will exist to the MQ. Okay. So for that purpose, we will use MQ.
Okay.
What is MQ? MQ is a middleware platform, as I said.
Yeah.
It is a Middleware product, and is a product of Ibm.
Okay.
Okay. So in this major role is placed with the queue manager. MQ contains queue manager. So in this queue manager, we will derive all the objects. So this queue manager will control all objects within the queue manager. Okay. And MQ runs with all the platforms. It's a platform independent. Okay, it will run in the Linux, it will run in the Linux, AX, Solaris, Mainframe, Windows.
Okay.
So anywhere you can remotely install, but suppose the tags will be different. For Linux, you have to install Linux tag, and for AX tag. Like that, you have to install. Okay. In one server, we can able to create a number of queue managers, but according to the space. So this queue manager, for example, in server, they have given some GB. Like in Linux, they have provided some like 10 GB or 20 GB. According to that, we have to create how many queue managers we have to create. We have to analyze according to the queues. What is the message flow rate? So how many messages will come and how many messages will store into the queue? If application not able to pick the messages, if that message will be stored into the queue, then how much space it is occupied. According to that, in the server, we will create queue managers. Okay. Most of the times in production and security, we will maintain only one queue manager per server. And in damage testing, we will create 3 or 4 queue managers. Okay. Depends upon the size. Okay. What Linux team and Unix team provides the file systems are inside, we'll go. Okay. We'll create. Okay. So there is one. The extension takes care of all the storage, logging and communications. Okay. So all the storage and it will be different. Installation part will be different and hello.
Yeah, I'm listening.
Yeah. Okay. So it will be like installation path will be different and whatever working directory will be different. Whatever we are creating, queue managers, queues, that will be different. Okay. So advantages of MQ. What will get the advantages using MQ? So main advantage is triggering. So triggering in the sense if you want to start any application automatically. For example, if you want to open one notepad or if one message is coming into the queue, then we have to run something else. Like another application we have to run. Once message is coming into the queue. Or else, if, for example, set of queue, number of messages is coming into the queue, then we have to start one application automatically. So at that time, we will use triggering concept, and we can start the application using this. Okay. And confirmation of message arrival, then delivery. So once message coming into the queue, we can give the confirmation how many messages are in the queue. Okay. Then delivery also, how many messages are delivered. So in the queue we can able to tell. But we have to do it once delivery. Once message is delivered, then we can't be able to return. Okay, and guaranteed one-time delivery. Guaranteed, why it is guaranteed in this way? If the queue manager is installed, then there is a possibility of or else file system got corrupted. Okay. At the time, there is a possibility of message going to lost. But in MQ, the message will exist. Okay. And load balancing also we can able to do. And as I said, we can able to install in Unix family, Linux, Console and mainframe, Windows. That is, we can use it any platform. Okay. So this is what a local queue. For example, the application A is putting message into queue and B is picking up. This one. Okay. Pictorial diagram. Okay. So this queue will be controlled by the queue manager. On this top we will have queue manager. Okay. All these queues will be exist. This is what we will call objects. This queue. Okay. So there will be communication in. So in MQ we talk about message, right? Yeah. So message would be anything. The content will be Java or else text or else image or else video, something exceptional coding, anything. We don't deal with the message. Okay. What is inside the message? We don't deal with the message. It would be anything. Okay. We won't deal with any message. So message communication will happen in both two ways. One is synchronous message communication and second one is asynchronous communication. Okay. So communication will happen in two ways. Okay? Yeah. So what is synchronous communication? Synchronous communication is an application A is putting message into one queue. For example, Q1. Yes. Okay? From there, application B is picking up. Okay. So using MQI calls, I will tell you later what is MQI call. So using, so from Q1, application B is picking up. Again, that message is putting into Q2. Okay. So after in the middle, some modifications will be done by some other application. Okay. So again, that message is putting into the Q2, and from Q2, application A, again, application A is picking up. Okay. So this is what chain model, like application from A to B, A to Q1, and Q1 to B, and B to Q2. And B to Q2, okay. And Q2 to A. This is what synchronous model. Yeah. This is synchronous communication. Okay? Okay. And there is one more thing, asynchronous communication model. Okay? And asynchronous, there will be like, we are putting A is putting in Q1, and from Q1 to B is picking up, and B is putting in the Q2, and from Q to C, third party is taking up. So we'll see asynchronous communication. Then MQ will have two types of communication, synchronous and asynchronous. Okay. So this is what message queue interface. So what is message queue interface? I'll tell you. So as I said, queue manager will control. So here, queue manager will control all the queue objects. In the below, you can see that this symbol, last symbol is in the symbol. Those are queues. Okay. Okay, queues. So those objects will be controlled by queue manager. Okay. So application A is putting messages into the queue, connecting to the queue manager and putting messages into the queue. Okay, using MQI calls. So what are MQI calls is? Here we have MQI calls. This is MQI calls. Sorry. So major calls. We'll explain you all these MQI calls, how the queue manager is ended. I'll explain you each one by one in another class. Okay. So this is the introduction. Using MQI calls, application it connects to the queue manager. From there, he will pick up the queue, and in the queue, puts the message. From there, application will be able to pick up the message. Okay. So, in this, as I'm saying, queues are empty objects. Queue manager will control the objects, those are queues, I'm telling you. Right? So, those are, there is a types of queues. So, these are all types of queues. Local queues, transmission queue, remote queue, alias queue, cluster queue, model queue, regulated queue, and default queue. Each and every queue has their own features. So local queue will store some messages. Okay. So storing the message purpose. So we will use that local queue. And next one, transmission queue. Transmission queue will pass the message. It will pass the message to channel. Okay, and remote queue. This remote queue has their own purpose, an alias queue. So I'll tell you in brief once concepts is coming into the picture. Each and every queue, what is the purpose? So, okay, default queues. Default queues comes when you install the queue in the system. When you install MQ in the system, all default queues will be created. There will be 77 default queues. Okay. So using the default queues only, the local queue transmission queues will take the feature and it will function according to that. Okay. Using the default queue features, it will take the feature and these queues will act accordingly. If there is a corruption of, if default queues will be corrupted, then these queues functionality will be changed. It won't work. Okay. So there is a channel. So using MQI calls, application is connected. Using this communication channels only, they will connect to the queue manager and insert the queue. So these are the types of channels existing in MQ. Sender, server, receiver, cluster sender, cluster receiver. These are all channel types. So these channel types also comes to the picture when we go brief about subject. Okay. This is a combination of channels. If sender channel will be existing, then we have to create one receiver channel must and should. Okay. If requester channel, in the sense, we have to create server channel. Combination of channels. Okay. As the client connection is existing, server connection. And cluster sender, cluster receiver, we have to create with the same names. Yeah. So then only binding will happen and channels will come into the multiplication. Okay. Yeah. So these are all topics of it. So as I said, there are different types of how queues are made, right? So in this topic, we will use those queues and channels also. Okay. So in MQ, we have distribution setup or point-to-point setup. Okay. So in this, what will happen? Application A puts the message into queue manager A. From there, message will be passed into queue manager B. Okay. Okay. From queue manager B, application, so another application will pick the message. Okay. Like in distribution setup, this is what happens. Okay. So why we use distribution setup in this? For example, one server is existing in India and another server is existing in Germany. Okay. There will be firewall blocking in between them. So in the sense, Germany people can't able to connect to the India server. Yeah. Okay. And same as India people can't able to connect to Germany people. Why? Because firewall is existing between them. Okay. At that point, we will create this setup. It is distributed setup. Right. Okay. So in the sense, India server. In India server, if we put the message, the message will go to the German server. From there, the German people will pick up the messages. Okay, and the same way, if the Germany people will put the messages, then it will come into the India server, and from there, India people will pick the message. Okay. Okay, that's it. Distributed setup. And next one is client server architecture. Okay. So client server architecture, what will happen? So some application, Java application is directly connects to the queue manager using channels and port number. So it's not like there will be no firewall rules in this. These both guys are in same firewall. Then we will use client server architecture. Okay. So and triggering. Triggering in the sense if we want to start any application automatically, like I said, if we want to start any application, if some messages will come into the queue, then we have to start any application. We want to run any application. One message is arrived into the queue, then we want to start one daily application or something. Then we use triggering concept. Or if you want to open any notepad, by using triggering, you can able to open it. Okay, and the topic is cluster. So cluster is used for group of queue managers. If you want to share the load balance, as I said, in MQ we can able to do load balance also. If application A is putting 5 to 10 lakh messages, so then if the 10 lakh messages will go into the one server, then server performance will be so slow. Then there will be a possibility server might pile up and queue manager will go into the down. Okay, file system will be doing, then queue manager will go into the down state. To reduce that, we will change the message in workload pattern. So for example, application, Java application putting the message in. The workload will be shared among the cluster. The cluster contains 4 key managers. Then the messages will, the 10 lakh messages will share among the 4 key managers. Okay. And designator handler and designator header. That is another concept. Authorizations. Authorizations represents permissions. You want to provide permissions to the users who will connect to the which queues. Okay. So for that purpose, we will use authorizations. And MQ records. So applications, how applications will connect the queue manager queues. MQ records we can able to. Okay. Logging methodology. So how better logs will be recorded, how transaction logs will be recorded. These scenarios comes under log concept. Very concept. So publisher and subscriber concept. Okay. So these concepts will be explained. Okay. So I will show you one scenario how we will put the message in queue. So you know about these things? I'm sorry? So how to create a queue manager, how you...
Yeah, I know. Okay.
So I'll show you. Using this PRGMSM command.
Okay.
So once we create a queue manager, have you ever created this queue manager?
Yeah.
So in this, once we create it, we can show display the how many days trial period is existing and how many objects created. These are default objects which is created 77. Okay. And in which part queue manager is created. This is installation directory. Okay. Queue manager is one. This is created. Okay. Then ESP. So you can ESP. You can display the queue manager's status. So what is the status?
I think you have to create a start.
Ibm Mq displays all the queue managers.
All the queue.
So which are existing in the system, it will display all the queue managers. Okay. So already I have created queue. So the status is already in running state. Now I have created queue in that. I didn't start it. So it's show you and just
Immediate.
now I am If you want to see specified queue manager, only one queue manager,
Yeah.
and then a queue manager. So you can see specified queue manager starting.
Okay.
Now I am starting the queue manager.
Okay.
Start the queue manager. So I'm checking the status whether it is started or not.
Okay.
The status is running. So here it's the installation one, the queue manager is created, and 5 log records. I'll explain you log concept.
Okay.
What is log records?
Okay.
While starting, we should display this.
Okay.
So if you want to go, as I said, in queue manager we will create objects. So to create those objects, we have to go inside the queue manager.
Okay.
For that, yes.
Okay.
So this is running QSC mode, and these are all DSP and these are all control commands.
Okay.
Inside running QSC, whatever commands are there, those are running QSC commands.
I'm sorry?
Running QSC commands. And these are DSP and CRT and those are control commands.
Okay.
So I'm defining one local queue. I'm creating one local queue.
Okay.
Okay. So as I said, first of all, I will show you the default objects. These are all default objects. So when we install them and show, these objects will be created. How we will put them in. I am defining one local queue.
Okay.
Queue local, and we have to follow the naming standard. Okay, I have created QM1 queue manager, so I am creating the same. Why? Because as an administrator, we will work in the shift. So if you are not in the shift, then other shift person should be able to understand what is the queue. But because we have different types of queues, right?
Yeah.
But similarly, he has to understand.
Okay.
Shift person. So there is a local queue. Okay, like that. That's why we follow the naming standard. Created. So I have created one local queue and I came out from the running QSC mod.
Okay.
Then
if you have to come to okay.
So you have to use edit command.
End command.
If you want to go again, command QSC. And display that queue is existing or display queue local queue. This is one that LQ, which I have created. It will display all this. These are all attributes of local queue. It will begin from the default queue.
Okay.
While installing default queues will be created from there.
Yes.
So in this measuring of this current date and max date.
Okay.
Okay. So if how many messages are there, we will make this current date.
Okay.
Then max date is how many max messages we can put. We can get it max date.
Okay.
Okay. So this is a brief description about the queue.
Okay.
Now it's